Yes, correct. Can we remember the three states of matter that we discussed last time? Yes, Brian.
So- Solid,
Solid, good.
liquid,
Liquid,
and gases. And
gases,
gases.
good. That's fine. So today we shall discuss on the dimensions and units and fluid mechanics in the unit of water supply. Now, direct to the topic dimensions. Uh, as you can see from my slides, I'm giving you the definition of dimension. Can someone read for us the definition of dimension from your end? Yes, read for us, Kerema.
The measure by which a physical variable is expressed quantitatively.
Quantitatively. So a physical variable can be expressed quantitatively. Now, dimensions can be categorized into primary dimensions and secondary dimensions. So when we talk about primary dimensions, these are dimensions which are independent. And from the primary dimensions, all the other dimensions can be obtained. So in fluid mechanics, there are only four primary dimensions, which are namely mass, length, time, and temperature. So from these four primary dimensions, then we can derive all the other dimensions. And now this gives us the secondary dimensions. The derivatives of the primary dimensions give us the secondary dimensions. So these secondary dimensions is simply a combination of the four primary dimensions. Now, for example, when we consider the Newton's second law of motion, uh, force which is mass by acceleration, then the dimensions of
Anda azwe grase que kyo yonde am promise. Ano tingo taka como sareri.
can we have some order, Kerema? Yes. Please just unmute your mic when you have something to respond to. Uh, but other that time, let's keep mics muted so that we can have some order. So I was saying that dimension, like I was giving the example of the Newton's second law of motion, which states that force is equals to mass by acceleration. So the mass is given as m, while acceleration, which is simply the rate by which a certain length is or a moving body surpasses a certain length, the square of that time or rate, then F being m times a, we can represent the acceleration as the length over the square of time, which means it will be L over t squared. So basically, the m and a, those are the dimensions of mass, and a, the dimension of acceleration, giving us a secondary dimension of which is now force. So force by itself is not a primary dimension, it's a secondary dimension. Again, like we consider the example of power using the formula of power. You know, power is basically the rate at which work is done. So work is force by length, and already we know force is m times L times T inverse squared. So that rate by which work is done is taken as mlt negative 2 over t, then we multiply by length. Then we multiply by length. Now, the other thing is on unit. A unit, which is a way of assigning a number or a measurement to a dimension. So we have three primary ways in which we can express that, or the unit systems that are used. We have the international system of units, or the SI units. For example, the kg, the N for Newton, M, S, and K. Then we have the English engineering system of units, commonly called the English units, and we have the British gravitational system of units. So units must always have numbers associated with them. For example, if it's length, we have dimension, but it is measured in units of feet or meters. So we have this table which is giving us the dimensions and the units. Like the dimension length, its unit is meter or m. Dimension mass, uh, its unit is kilogram per kg. If it is dimension time, its unit is second. If it is dimension temperature, its unit is Kelvin. Its unit is Kelvin. So we have a summary of uh, the dimensions and units. Like we have the quantity mass whose dimension all simple is m, because we've said a dimension is simply a notation of a physical quantity. So the dimension m, the units can be in grams, it can be in kilograms, and so on. So that table is simply a summary of the dimensions, the units, how it is expressed. And I've said that this is not a full table giving us all the dimensions, just a table which is giving us the primary dimensions and a single secondary dimension which is force, whereby we have so many other secondary dimensions that we can derive from the primary dimensions. So with that information, now one is able to quantify different different uh, items using the units, having known the dimensions. So commonly we use the ESA units, which is the international standards units that are used worldwide, but different countries have adopted special units, like in Britain and so on. So the ESA units will be commonly used as we go on with this topic, because now that these are single annotation, it will help us to symbolize uh, or annotate different items, so that you can easily relate one item and the other. Can easily relate one item and the other. So that is all in dimensions. I'd like to know whether there is anyone with a question on dimensions and units. Do you have a question? Anyone with a question on dimension or units? Yes. Saruni, you have a question?
No, I don't have a question, Mwalimu.
Yeah, that's good. Now let's have a recap of what we've learned. What can you recall from today's lesson? What have you learned? Yes, what have we learned from today's session?
We've learned about the dimensions of the dimension of quantities like mass, length, time, temperature, and force with their SI units.
Very good. So that's a good
Yeah.
uh, understanding. Yes, somebody else? Mireo, what have you learned?
We have learned to define the units,
Yes,
such as a unit is actually an annotation about some measurement.
yes, that's very correct. So uh, that is part of what we have learned. So with that, I'd like us to end our lesson there. And before we end it, I'd like to give you an assignment, so that during your free time you can undertake it. So this assignment involves uh, writing down the SI units for the following items. You just write down the SI units of the following items. Uh, Write it somewhere. You can write it on your notebook. You write down the SI unit of mass, length, time, temperature, and also give the annotation. Give the annotation for work. Give the annotation for work. So that is the assignment. We shall check on it the next time we meet. So if you have no another question, we can end the lesson there. So have a nice time.